Unlike the normal situation of nuclear power plant decommissioning, we do not completely understand what is happening with the nuclear fuel inside the reactors of the Fukushima Daiichi nuclear power station. That is because there are areas within the reactor buildings with high amounts of radiation, making it difficult for people to approach them. For that reason, remotely controlled robots have been used to carry out decontamination and rubble removal along with on-site investigations since the accident at Fukushima Daiichi first happened. The development of such robots has been the fruit of cooperation among various domestic and foreign manufacturers. They include iRobot, famous for its robot vacuum cleaner Roomba, as well as such companies as Toshiba, Hitachi, and Mitsubishi, in addition to universities and research institutions. Not only is Fukushima Daiichi the site of reactors to be decommissioned then, but also somewhere in which state-of-the-art technologies, being developed by various companies, are being put into practice at an actual site.
Decommissioning Fukushima Daiichi is an unprecedented project which will take 30 to 40 years to complete. We are employing technologies in various fields, such as nuclear, mechanical, electrical, and civil engineering, and incorporating the wisdom from countries such as the United States, United Kingdom, France, and Russia, which have the experience, technologies, and skills required in plant decommissioning. Robotic technologies is also actively used in areas such as decontamination, the investigation of leakage, and the removal of radioactive rubble. So, on the site, you are actually able to handle challenging and state-of-the-art technologies.
The robot being shown was developed by Hitachi GE Nuclear Energy Limited to investigate the interior of the reactor vessel of Unit 1 at Fukushima Daiichi. The fuel that has melted at Unit 1 is thought to have fallen onto a base inside the reactor vessel that is known as the pedestal. Given the possibility that fuel debris has spread to other areas outside the pedestal, the aim is to take images of the exterior of the pedestal, as well as to get data on such things as temperature and radiation levels. This so-called shape-shifting robot can snake through pipes, measuring as small as 10 centimeters in diameter, in order to get inside the reactor vessel. Once inside the reactor vessel, the robot changes its shape into a right-angled U, and then makes its way while avoiding obstacles. The robot sends data using the investigative camera, thermometer, and dosimeter that have been installed on it.
When I was a student, I majored in physics. As nuclear energy calls for an extremely high level of reliability, I feel that it is a field worth pursuing. I have also felt it very much worthwhile to bring new ideas into actual reality.
The development of such technology does not happen overnight.
We started developing the technology for the reactor's decommissioning as a national project around December 2011. As a matter of fact, though, we started the technology's development even earlier, thinking and doing various kinds of things ever since the accident first took place in March of that year. We made proposals about a variety of tools, concerning such things as going to look at the spent fuel pool and actually put those proposals into action.
Before new technologies are actually realized on the site, examinations known as mock-up tests are carried out repeatedly using equipment and facilities that simulate the site.
Come to think of it, what caused us the most trouble once things actually started to take shape was the stage of applying it to the situation at the actual site. That stage was really tough. We had to think of all the different situations that might arise, after which we performed mock-up tests on them, while also re-gearing the equipment to match each situation. Come to think of it, what caused us the most trouble once things actually started to take shape was the stage of applying it to the situation at the actual site. That stage was really tough. We had to think of all the different situations that might arise, after which we performed mock-up tests on them.
I hear that an indispensable part of the process of developing new technologies is getting young people to freely come up with ideas. Many difficult problems are known to have been overcome in the past by getting the members of a team, composed of young people and veterans from a wide variety of backgrounds, to engage with each other in a lively debate.
Construction-related work in particular involves a whole lot of people. Basically, I think that a person needs to have communication skills, such as speaking, listening, and conveying ideas in that work. In my opinion, I would like to see those students aiming to do such work in the future polish those kinds of skills.
This work we do is a bit different from the type of work we did before. Moreover, it's the first time for everyone to be involved in this kind of work. While it goes without saying that veterans have some background in the nuclear field, it is also true that they are facing an entirely new challenge. Just because someone is young, then, doesn't mean that he or she is way behind the older people at the outset. So, I would really like for you all to jump right into it.
Since it was we who originally designed and built Fukushima Daiichi Unit 4, we have always referred to it as our plant. For that reason, when the earthquake damaged the various facilities of our plant, including those at Fukushima, we automatically felt compelled to get together and do something, as we felt our support was needed there. That situation has lasted from the moment the March 11, 2011 disaster struck, right down to the present. There is a wide range of problems, starting with the contaminated water issue, as well as robotics-related ones, and those involving the special properties of debris, among others. We would really like to continue pursuing the challenge of resolving those problems with our team of engineers who come from a variety of technical fields, all working together toward a single goal. We also greatly look forward to getting young people to participate in that challenge.
We have received and actively used advice from overseas countries on water and other decontamination process. I will continue to work with engineers around the world and use their wisdom to meet the challenges of working in high-dose areas and removing nuclear fuel debris safely. I will commit to sharing that knowledge with the world.